Hello, grade sevens. In today's lesson, we are going to look at an alternate way of subtracting integers pictorially, this time using number lines. I suspect that you are going to like this method a lot more than the subtraction method using the integer chips, as admittingly, the implementation of the zero pairs as a workaround to perform the subtraction with the chips was quite confusing. However, before we can actually look at the number lines themselves, we need to start off by examining some subtraction rules for integers. And here's how the rules work. 1. Subtracting a positive integer is the same thing as adding a negative integer. Let me give an example of this. If I have positive 4, subtract positive 2, what this rule tells me is I can rewrite this statement where I have positive 4, subtracting a positive integer is the same thing as adding, so I'll put a plus sign here, a negative integer. Let me give you a little analogy to make some sense of this. So let's say that your personality, your mind, your body, whatever, contains both some positivity and it contains some negativity, maybe some positive thinking, some negative thinking. So let's say that we wanted to, if I look at the statement here, I wanted to remove, which is what subtraction means, remove some of my positivity, remove some positivity. I suspect that if I removed a positive aspect of myself, I would be more negative. And if I look at this here, if I go positive 4 plus negative 2, it's like I'm adding some negativity. So positive 4 subtract positive 2 would be like you're subtracting a positive aspect of yourself, and that is equivalent to adding a negative aspect. They just mean the same thing, except on the right-hand side, I have this written as an addition statement compared to a subtraction statement. Rule 2. Subtracting a negative integer is the same thing as adding a positive integer. Okay, so let's pick a different one. Different examples. Let's do positive 3. And this time I want to subtract a negative integer, negative 4. What the rule tells me is if I subtract a negative integer, subtracting a negative integer is the same thing as adding a positive one. Let's go back to my ridiculous analogy of you consisting of positive and negative aspects. So think of this. If you removed a negative aspect of yourself, I would expect myself to be more positive. So removing a negative aspect of myself might be the same thing as adding some positivity. They're just equivalent statements, except one is a subtraction statement, one is an addition statement. So hopefully that analogy makes a little bit of sense. I'm sure there's better ones to use, but it's the one that I think about when I try to memorize what these rules are. Okay, now it turns out, with the exception of just the two subtraction rules, there's not a whole lot different we need to do to actually complete the operations on the number line. However, let's just first of all practice these subtraction rules, then we'll get into the number lines. A. So what I want to do is I want to rewrite these expressions as the sum of integers, although I don't actually want to perform the calculation. So I have A, negative 4, subtract positive 11. B, negative 5, subtract negative 6. So for part A, let's see, I don't think we have a part C. Okay. So for part A, what you're doing is you're subtracting a positive integer. Subtracting a positive integer is rule 1. Subtracting a positive integer is the same thing as adding a negative integer. So this would turn into negative 4 plus positive 11. And again, I can see here, subtracting a positive is the same thing as adding a negative. Okay, they're just equivalent statements. B, -5 subtract -6. Well, that would be rule 2. So you're subtracting, let's look right here, subtracting a negative integer. Subtracting a negative integer is the same thing as adding a positive integer. Therefore, this would turn into -5 plus +6. So again, subtracting a negative integer, the exact same thing as adding a positive one. Now, as long as we have these two rules memorized, performing the calculations on a number line, there's nothing different in comparison to how we did this with adding using a number line. So let's do a few examples here to show this. I think just 2 of them actually. So I want to subtract the following using a number line. The one thing you have to do before you start to draw anything on the number line is you need to turn these subtraction statements into a positive statement. A positive statement means you need to apply rule 1 or 2 from the previous slide. So the first one, I have +3 subtract +6. So what I'm doing is I'm subtracting a positive integer. I believe that's rule 1 on the previous slide. Therefore, that would be +3 plus -6. Subtracting a positive is the same thing as adding a negative. Now, all we have to do is just plot exactly how we did with the number line from before. After we turn it into an addition statement, well, now it's just like adding using a number line. So what we do is we start at 0. That's our reference point. And then we represent the first integer on the number line. +3 means go 3 units towards the right. So I go 1, 2, 3 units to the right, draw my arrow, and then label the integer directly above. That's +3. From the end of the first integer, the arrow, you want to then start the second one. So the second integer tells me then go 6 units to the left. So what I do is I would start here, and then I want to hop 6 spaces to the left. So I go 1, 2, 3, 4, 5, 6. So I'm going to end up on this spot of the number line. If I draw that, it would look like this. Okay, we start at the end of the first one, and then we go 6 units to the left. So let's label that. That'd be -6. And then the actual answer would be, well, just look at where the second integer ends up. The second integer ends up at, well, on the number line, it's -2. Sorry, -1, -2, -3. Therefore, +3 subtract +6 is the same thing as +3 plus -6, which would just be equal to -3. B, -4 subtract -6 equals, if you want to find that difference, first things first, you want to turn this into an addition statement by applying one of your 2 subtraction rules. So now we're going to apply rule 2. So in this case, we are subtracting a negative integer. Subtracting a negative integer is the same thing as adding a positive integer. Once we turn it into an addition statement, then we just simply use a number line like we did in the lesson on adding integers using a number line. Starting at 0, the first integer is -4, which means draw an arrow going 4 units to the left. So 4 units to the left is negative. Write -4. And then directly above, at the end of the first arrow, we then start the second integer. The second integer wants us to go 8 units to the right. So we start here and we hop spots. 1, 2, 3, 4, 5, 6, 7, 8. We're going to end up right here. So let's draw that second integer. Label that as +8. And then This would be on the number line, that's +1, that's +2, that's +3, that's +4. Therefore, -4 plus +8 would be +4. And that's the same thing as -4 subtract -8 according to our subtraction rule. Personally, I think this is a lot easier than using the integer chips. And to be frank, moving forward, we tend to use number lines a lot more in mathematics than the integer chips. So it's more important we have a better understanding of the number line than the chips. However, for the grade 7 level, there is an expectation you do understand how to properly use the chips to model integer subtraction pictorially. Although afterwards, we're probably not going to use chips a whole lot. In fact, much later on in math, we're not even going to draw number lines. We're simply just going to write the statements down and perform the operation. Okay, so the assignment to complete in your MathLink 7 textbook on pages 333, 334, numbers 5, 6, 9, 10, 11, 12. 5 and 6 are just practice of turning a subtraction statement to an addition statement, so they're pretty quick. Numbers 9 and 10 say subtract the integers. I want you to do this with number lines. (11) and 12 do not use a number line. The numbers are huge. You'd be drawing like humongous number lines to do it. What I would do for 11 and 12 is they're word problems. Read the word problem, write down the subtraction statement, turn the subtraction statement into an addition statement, and then just perform the calculation. And then hopefully at this point, you can perform those calculations without the aid of a number line or the integer chips. Okay, so this is the last lesson in the integers unit, and I will talk to you in the next unit of study in math.